Hi. During the class, we've seen that the tool chain or any tool chain consists of several subtools and what their behavior or at least what their function was. And in the next assignment you are going to set up a complete project from zero, from scratch. But I want to show you some things for now so that you know where you can find it and what to do. As you know, we have our options here, right mouse button, and we have our options. There are several tabs. One of the things here is that you have to define a device that you want to use. For the example, we're using the Tiva C series, and in this case we have this target processor. That's the only thing that you can select here basically. Target here tells us something about the properties of the chip itself, and mainly where our ROM, internal ROM, which is the flash that we have discussed. You can see that the flash is 40,000 hexadecimal in size, and we also have 8,000 hexadecimal, which is 32 kilobytes of RAM on the chip. Further, you can see here that we are using our version 6 compiler, and here it says floating point hardware, which means that it says single precision, and you can choose also not used, but we default to single precision, which means that the hardware that can compute with floating point numbers that is present on the microcontroller itself is being used. Output tells us the name of the file that will be generated. Well, I never change it, so you see some stupid name here. And here you can decide if it is a program that you can run on your target, or if you want to create a library in this project. Listing is something that we don't use for you. User also is being ignored, and here we have the C++ options. As you can see, we use a default define that is being used for every file that's being compiled. We have some compiler optimization settings that we can choose. Every optimization has a different result regarding size of your program and the speed that it will run in. Some warnings level, we are using the AC5 level because that doesn't introduce too much warnings that you don't want to have. As you can see, different kind of C language standards, same for C++, as you can see here, and some other options that we normally ignore in your case. Here you can see the include paths and where are they used for. I have to cancel it for now. Here in the tree we normally add your C and CPP files that have to be built, and I also include all kind of header files for you. And this is mainly so that you can open the header file and find most things very quickly. But for the building process, every header file that's present here does nothing. So whatever you add here is only for your own reference and not being used during the building process. The C++ files are being used. The library file is also being used to build your program. So how does the IDE, in this case, know where to look for header files? That's on this tab, is the set of paths that's given here. So I have 4 paths, and I should double click on. Here you can find or define where you have to search, and that's something that you will have to do during the assignment. So the include paths are all the directories where the toolchain during compilation will search for header files that are necessary to build your program. So, as I said, these in the tree are useless for the building, but only as a reference for you. We don't use the assembler, linker likewise, and the debugger you already know where. Here we decide or say which interface we want to use, or we are using the simulator. Yeah, that's about it. A short introduction to everything that's on the tab, and you will explore them more and better during your next assignment. Thank you for watching, and until next time.